The last time that we met, we talked about IPv4 addresses. We talked about the subnet mask and converting those all into binary. The subnet mask, again, tells us where to draw our line. Everything on the left-hand side is part of the network. Everything on the right-hand side is the host portion. So if I give you an address like this, 192.168.1.15 with a slash 27. What we want to do is convert this into binary, draw our line at the 27th bit on the right-hand side. That will determine which part is the network, which part is the host. Just to recap here, 192 in binary is this. 168 in binary is this. 1 in binary is this. And a 15 in binary would be this. With the slash 27s, I could draw out 27 ones because that's what the slash number means, is how many ones I have in my subnet mask. So I could draw out all 27 ones if I wanted to. What I'm going to do in this example is I'm just going to go over to the 27th bit. It's the 24th, or the 25th, 26th, and 27. And I'm going to draw my line. So everything on the left-hand side is the network portion. And if I change this right-hand side here to all zeros, that gives me my network ID. So that number right there is 192.168.1.0. That is the network that that particular PC is on. When I have the right-hand side all ones, the host portion is all ones, that number tells me the broadcast for the network that that PC is on. This would be 192.168.1. This number here is 31. The 192.168.1.31 is the broadcast for the network that that PC is on. The network we said was the 192.168.1.0. The first usable host that we can have on a network is when we have all zeros and the last digit a 1. So the first usable host on that network would be 192.168.1.1. And the last usable on this network is when we have all ones, except for the last one being a 0. So the last usable on that network is 192.168.1. Here I have a 16 and an 8 is 24, and a 4 is 28, and a 2 is 30. So 192.168.1.30. So my range effectively that we came up with is 192.168.1.0 as the network, 192.168.1.31 as the broadcast, the 1.1 as the first usable, and the 1.30 as the last. We want to get into the habit of converting our IP addresses and subnet masks into binary. Tell us where to draw our line, and we can figure out first and last and broadcasts and network IDs pretty easily when we do it that way. That's what the subnet mask does for us, determines what part is the network and what part is the host. Okay, in this example, they use a slash 24. So where they draw their line is right at that separation between the third and the fourth octet here. So right at that dot, they use a slash 24. And again, when all zeros are on the right-hand side of that line, that's our network address. So all of these PCs in this example are part of the same network address. Figured out their network address, it's all going to be the same. 10.1.1.0. Any specific host has a combination of zeros and ones in the host portion. Any specific host on that network has a combination of zeros and ones. And then the broadcast is all ones. And again, a broadcast is when you want to communicate with every single device on that network. It's kind of like shouting on the network saying, I want to communicate, I want to tell everybody on this network this particular message. Next thing I want to talk about is binary ANDing. Binary ANDing is what a router or a device does to figure out what network it's on. It doesn't draw everything out in binary and draw a line and make the right-hand side zeros. It goes through this ANDing process. And we've done this before in the past, but I want to review it again. The rules for ANDing is a 1 and a 1 is 1. Anything with a 0 is 0. So if I have a 0 and a 1, that's 0. If I have a 0 and a 0, that is 0. So only a 1 and a 1 is 1. Everything else is a 0. I'm going to turn this off for a second and draw this one up on the board, and we'll go through it here together. So what I have here is 1, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, and then 0, 0, 0, 0, 1, 0, 1, 0. And you're going to AND that with the subnet mask. So you always take your IP address and you AND it with your subnet mask. And what this is going to do for you is tell you the network that you are on. So if you ever get a question, here's an IP address, what network is it a part of? Just AND together the IP address and subnet mask. And the subnet mask that they had there was the standard 22255.0. And that's 24 ones. The 22255.0 is /24. So what you do is you take a look at the 2 bits, a 1 and a 1. Draw my line here first. A 1 and a 1 is 1. I'm not adding them or ANDing them. 1 and a 1 is 1. A 0 and a 1 is 0. 0. 0, 0, 0, 0. 1 and a 1 is 1. A 0 and a 1, 0. Anything with a 0 is 0. 0 into 1, 0. 0 into 1, 0. 1 into 1 is 1. 0 into 1, 0. 1 into 1 is 1. 0 into 1, 0. 0 into 0 is 0. Anything ANDed with a 0 basically becomes a 0. So what we do if I convert this back is I get 192, 168, 8 and a 4, that is 12. 8 and a 2, that's 10. 10.0. And what I started off with for my address was 192, 168, 10.10. So the IP address of 192.168.10.10 with a /24 or 22255.0 is on the network of 192.168.10.0. Take your IP address, convert it to binary, AND it with the binary equivalent of your subnet mask. And what you end up seeing is anything ANDed with a 255 just falls right through. This 192, we ANDed with all ones, it just fell right through. The 168 fell right through. The 10 fell right through. So a lot of times when you do ANDing questions, you'll just AND the last octet. I could have just ANDed this to figure out that last octet because I would know that that 192, the 168, the 10 are just going to end up falling right through. So let me give you another example here. Someone on their computer quickly do an IP config and tell me the address they're getting from BSC, and we'll AND that address with BSC's subnet mask and see if we can figure out what BSC's network ID is. 165, 234, 63, 23. And the subnet mask? 255, 252, 0. Okay, I'm going to drop my chart again so I can do my conversions. That's my 8 bits. Values below start with 1, double as I go to the left. 8 doubled is 16. 16 doubled is 32. 64 doubled is 128. So I need to convert these both into binary. The 165, I I need the 128 and the 32, which is 160. I don't need the 8, I need the 4 and the 1. One off here. The 128 and the 32 is 160. I don't need the 16, I don't need the 8. I need the 4 and the 1. So that's 165. 234. I need the 128 and the 64 and the 32, which is 224. I don't need the 16. I need the 8 and the 2. That is my 234. 63. I don't need the 128 or the 64, but I need the 32, the 16, the 8, the 4, the 2, and the 1. And of course, I'm running out of space here. And 23 is the 16, the 4, the 2, and the 1, right? Okay, so that's my IP address. Subnet mask, a 255 is simple. All ones. 252 is everything except for the 2 and the 1. And then the 0 is just 0. Okay, so I'm going to AND these. I'm going to try to figure out the network ID that this address is a part of. I'm going to AND them together. If I was doing the drawing of the line, I would draw my line right here. Okay, I'm going to do the ANDing process. We know anything ANDed with all ones just ends up falling right through, so I can do that pretty simply. 1 and a 1, 1, 0, 1, 0, 0, 1, 0, 1. Any questions with how I'm doing that? 1, 1, 1, 0, 1, 0, 1, 0. Just falls right through because it's ANDed with all ones. Over here it's going to change a little bit probably. 0, 0, 1, 1, 1, 1. 1 and a 0 is 0. 1 and a 0 is 0. And anything ANDed with zeros ends up being all zeros. Convert that back into decimal. This number here is 165. This number here is 234. This number here is 32 and a 16 and 48, and an 8 is 56, and a 4 is 60, and a 0 is just 0. So the 165.234 63.23 address with the subnet mask of 255.252.0 is on the 165.234.60.0 network. And it has the same subnet mask, which would be a slash. Here's 8, here's 16, 17, 18, 19, 20, 21, 22, 1, slash 22. So BSC is using a slash 22 network. So on BSC's network here, how many possible PCs can I have? Well, what's that? 20? It's going to be a little bit more. What we have to do for that is draw our line. We draw the line right here because the subnet mask changes from 1s to 0s. And it's 2 to the power of how many digits I have on the right-hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 to the 10th power, which is what? 1024. Minus 2 off of there, and the reason why I have to minus 2 is because I can't use the network ID or a broadcast to assign to a PC. And I get 1,022 computers or devices that BSC can have on their network with this as the ID and that as the subnet mask. So we want to start using that ANDing process to figure out what network we are part of. We know that in order to get an IP address in a Windows system, you go into the network card properties, you go to TCP/IP version 4 into properties, and it's going to pull up this window here for you. The two ways in which we can get an address for a device is either statically, which means you're going to manually put it in there, or dynamically. Dynamically means you're going to get it from a DHCP server. When you manually put IP addresses into devices, you want to have good record keeping because we cannot use the same IP address for two devices on the same network. They have to be unique. So make sure you're not duplicating that address. With DHCP and dynamic assigning of addresses, that DHCP server keeps track of which addresses are out and how long their lease is, and they will not duplicate the address. Pretty much all IP addresses that I've shown up on the board and done examples with are unicast type of IP addresses used for unicast transmission. With unicast transmission, we're going to go from one device to the next. The PC on the left there is going to send to the printer on the right. Unicast from one device over to the next. And most times when we're talking about communicating on a network, we're talking about unicast traffic. One device to another device. Think of a unicycle. It has one wheel, one device to one other device. A broadcast transmission. With a broadcast transmission, there's actually two types of broadcasts. This here is a limited broadcast, and the limited broadcast is all 255s. All 4 octets are 255s. With a limited broadcast, that gets stopped by the router. Notice how the router will put the X on it, and it will not forward it off to the next segment or to the next network. We also have multicast transmission. With multicast transmission, we're going to send from one device to multiple devices. But in order to use multicast transmission, those devices have to listen on a special multicast address. If you look at these two laptops down here, they have their own unicast address of 4.3 and 4.4, but they're also both listening to a multicast address of 224.10.10.5. We see a lot of multicast addresses when we're talking about routing protocol updates like OSPF and EIGRP. When we get into the routing next semester, we'll talk a lot about the multicast addresses. Another one that I'll have, I think there's an example of it, is what's known as the directed broadcast. And the directed broadcast is what we've been showing up on the board. An example of a directed broadcast is like this, 172.16.4. All 255s. That's when you draw your line and everything on the right-hand side is all ones. That is going to be your directed broadcast as opposed to the limited broadcast. With a directed broadcast, you could actually send that to the router to reach all computers on a remote network. So if you want to reach all computers on a remote network, you use the directed broadcast. For the limited broadcast, the router would stop that. And we'll get more into the directed broadcasts in Chapter 9 when we start doing subnetting. But I just wanted to introduce it here a little bit. So it gives us the address of 191.146.68.58 with a /26. It wants to know what the network address is, what the last octet in decimal is, what the full address is in decimal. It wants us to figure out all these different things. So let's see if we can do that. A few different ways in which we could go about this. We could do the ANDing process. We could go do the drawing of the line. I'm going to do the drawing of the line. So what I'm going to do is convert this into binary here real quick. So that is my IP address in binary. Hopefully there's no mistakes in there. But my subnet mask is a /26. So what I can do is I can count over 26 bits and draw my line. So this would be 8 bits. 16, 24, here's my 25th and my 26th bit. Okay? It says enter the last octet of the network prefix in binary. If I want the network, what I do is I make the right-hand side all zeros. So it wants me to enter the last octet into binary. Put all zeros in there. The last octet in decimal, 0. Enter the full address in decimal. Full address would be 191.146.68.0. Right? Yes. The broadcast address. The broadcast on the right-hand side is all ones. This is known as the limited broadcast. So the broadcast in binary is 00, 11, 11, 11. That in decimal is 63. The full broadcast is 191, 146, 68.63. First usable address. We said the first usable is when everything is zeros except for the last one being a 1. So we have this. 00, 00, 00, 00, 1. That address is just 1. The full address, 191, 146, 68.1. Last usable. Last usable is when they're all 1s except for the last one being a 0. That is my last usable address. That in binary is 00, 1, 2, 3, 4, 5, 0. That would be what? 62. Draw it out in decimal. Let's see if we got it right. Yes, correct. So one easy way to figure out all these values, what I like to do is you just figure out what your network is. 192.168.68.0. You figure out what your broadcast is, 63. First usable is always 1 more than the network, so 68.1. The last usable is always 1 less than the broadcast, .62. So if you know what your network ID is, you know what your broadcast is, it's easy to figure out what the first and last usable. First usable, 1 more than the network. Last usable, 1 less than the broadcast. There's a lot of good tools in the curriculum here to test yourself and to see if you are understanding the binary and all these different conversions. Like I said, I'd recommend going through some of these if you're a little bit fuzzy with some of this. Okay, I want to talk a little bit about private IP addresses. Private IP addresses are address ranges that anyone can freely use to set up networks. The catch, though, is that the private IP addresses cannot be routed out on the internet. If you want to be part of the internet, you have to get a public IP address, either from your internet service provider, or you have to go register for one through the Internet Association of Assigned Numbers. And typically, you'll just get one through your ISP. The IPv4 private addresses, if you do want to use this to set up a network and you do want access to the internet, you can go through what's called Network Address Translation, or NAT. This router right here would have to have at least one public address assigned to it, and it would be assigned to this interface. And essentially what happens is all of these private IP addresses would borrow that one public to get out to the internet. And that's what happens typically at your home, is you have Midcontinent or whatever your internet service provider is, and they assign your router or your modem a public IP address. And maybe it's 26.1.1.1. It's a public address assigned to you that you can freely use to get out on the internet. You're paying for that address. Within your local network at home, you probably have a wireless router. It's assigning PCs the addresses of 192.168.1.1 and 1.2 and 1.3. Well, these are private addresses. They cannot be out on the internet. So what happens is when this PC right here wants to get on the internet, he goes up to the router goes through the NAT process, lets him borrow the public address to get out to the internet. Then when the internet wants to reply back, he replies back to that one public. There cannot be two addresses on the internet that are the same. They have to be unique. So he knows that when he is replying back to the 26.111 address, he is replying back directly to you, the customer. And then your router would determine which one of the PCs from your private network requested that information from the internet. So private IP addresses, anyone can freely use to set up networks, but they cannot be routed out on the internet unless you're going through a process known as NAT. So anything that starts with the 10 network, you can use. So 10.0.0.0 through 10.22255. Anything between 172.16 and 172.31. 172.16 and 172.31 is a private IP address range. 192.168. Anything that starts with 192.168 can freely be used as a private IP address to create a network. So be familiar with your ranges. There are some special addresses out there that you should be aware of as well. Some of the special addresses are the loopback. We've talked about the loopback, the 127.0.0.1. If you ping the loopback address, it's essentially testing your TCP/IP stack to make sure it's installed and operating correctly. We have some link local addresses, also known as the API/PA addresses, automatic private IP addressing. That's the 169.254.some number. When you plug in a network card onto a network, it's first going to try to see if it can get an address through DHCP. If it cannot, what it will do is it will give you an address out of that range, out of the 169.254 address range. So if you're doing troubleshooting on a network connection and you notice it has an address of 169.254, some number, that's telling you that either no one has statically assigned address or it can't contact the DHCP server. There's a test.net address. The test.net address is between 192.0.2.0 and 192.0.2.255. Don't get this confused with the private IP address. The private IP address has to start with 192.168. Just because this starts with 192 does not make it a private address. And then we have some experimental blocks. That's the 240 and up. The 240 and up cannot be assigned to PC. Okay, last thing I'm going to talk about is the old legacy Class A, Class B, and Class C, because we'll still refer to some addresses as Class A, Class B, and Class C. But this is how they used to do it, is you went and you registered for an address, and they gave you either a Class A, Class B, or a Class C, dependent on your network needs. And if you had a Class A, you were forced to use a 255 with a 000 as your subnet mask. In your Class B, you're forced to use a 255.0.0 as your subnet mask. And Class C's were 22255.0. What they decided this wasn't a very good method of doing things. They were starting to run out of addresses. And they developed what's known as CIDR, C-I-D-R, Classless Interdomain Routing. And what that said with CIDR is we can essentially use any network ID or any network and give it any subnet mask that we want. So we could essentially turn like a Class C into a Class A if we wanted, just by manipulating the subnet mask. But with the Class A network, those are between 1 and 127. And how they came up with that range is they said the first bit has to be a 0. So if I have the first bit of 0 and then all zeros, that's 0. The first bit of 0 and all ones, that's 127. So they came up with that Class A range, 127. Now the problem with the Class A network is that there was only 128 of those networks available. But each network could have 16,777,214 hosts or computers on it. A Class B said that the first 2 bits were a 1, 0. So if I have a 1, 0 with all zeros, that's 128. A 1, 0 with all ones, that's 191. So for a Class B range, you're between 128 and 191. Subnet mask 22550. With this, there was 16,384 networks available. So each network could have 65,534 hosts. So a little bit more reasonable there, but probably still overkill with the amount of computers you could have on a network. Class C, first 3 bits were 110. So the range for that is 110 with all zeros, which is 192. 110 with all ones, which is 223. Subnet Mask 22255.0. With this, 2,097,150 networks available, but each network can only have 254 computers. So probably not quite as many computers or addresses for computers that you needed. So again, what they decided to go towards is the CIDR and the classless